So these problems where it says find the value of x, it's basically the same thing that we did the day before. The only difference is that they actually put the x value. The x value could be here, here, or here, but you're still doing the same thing. You're making this constant your exponent, and your base becomes your base of your exponent, or your log base, whatever you want to call it. And then this x goes to the right side, and then you just solve. Basically, you make sure you know how to use your properties of exponents, because we know that 3 to the negative 2 power is the same thing as 1 over 3 squared, and 3 squared is 1/9. So that would be the value of x. We did the same thing for part B. This x became the exponent of the base of 1/4. The 2 went to the right side, which became just a constant. And then we solved them. Again, we used our properties of exponents, because I could write 1/4 as 4 to the negative 1 power, which is times x, which is negative x. And then we could write, so we could have the same base. We know that 4 can be written as 2 squared. So 2 times that negative x becomes negative 2x. Since they have the same base, you drop the bases and you solve for your x value, which is going to be negative 1/2. You guys did C and D. Here are the answers after I explained it in class. On this problem, we had to describe the transformation from this function right here. So this was log 3 of x. And for the first part, or g of x, we added a negative. And that negative, what it does is reflects it over the x-axis. For the next one, we subtracted a 4 with the x. Anything inside your x, the parentheses with your x, is the shift to the either right or left, depending on what this number is. In this case, because it was a negative 4, it was a right shift to 4 units. This number right here, it's outside of the x, so this is a vertical shift, or either up or down, depending on what number it is. Since it's a positive 2, it's a shift up 2 units of this function. So in class, I mentioned that if there was no base log right here, it was the base of 10. So automatically, that should have been a 10. Most books and teachers, if it's just log base 10, they will not put the 10, because that's basically the parent function of it, the base 10. So also, we have nothing being added or subtracted with the x, and no vertical asymptote either, but I'm going to put the 0 outside. And think of it this way. There's nothing being added to 0, and there's nothing being added to the whole function, either up or down. The difference between logs and exponential functions is their asymptote. So for exponential functions and growth and decay, you had a horizontal asymptote. For logs and natural logs, you're going to have a vertical asymptote. So whatever this number being added here is, that's going to be your vertical asymptote. So we know our vertical asymptote, not x, sorry, because vertical means x. So it's going to be 0. Our domain, since that's going to be, we're going to have a asymptote at x equals 0. So this is our x equals 0. So our graph is either going to be the left of that function or to the right of that function. Most likely to the right of that function. So it's going to be all the numbers that are greater than 0. So we're going to have x as an element of the reals, such that x is greater than 0. All my values are going to be to the right of that function. Our range is going to be all the numbers, all the positive and all the negative numbers. So that is going to be y as an element of the reals. For your intercepts, super easy. All you have to do is solve. So I'm going to do my work right here. So 0 is equal to log of 10 of x. And all you're going to do to get rid of that log is raise it to the power of your base. So 10, and then raise it to the 10. So we know 10 to the 0 is 1. And this is going to go away, so that is just x. So that would be my x-intercept. So I'm going to have my x-intercept is going to be 1, 0. And now we are going to make our little t-tables. And the numbers I usually like to use for logs are 1 and the base. So 1 and our base, and my base is 10, so I'm going to use 1 and 10. So I'm going to have, and again, this is the function that I'm graphing. So I'm going to have log 10 of 1. And if you look at your properties that you wrote down earlier, log 10 of 1 would be 0. And log base of 10 is just 1. And this is just using the properties that we wrote down earlier. Once I graph that, so I'm going to have 1 and 0. So this is 1 and 0. And then I'm going to have 10. So I'm going to extend it 6, 7, 8, 9, 10. 10 and 1 would be right there. So I'm going to have a graph that kind of looks like this and across that point. So for this function, that -3 is not your h, it is your k, because it's outside the function. So that means my asymptote is x is equal to 0. So that means, again, this is my asymptote on my y-axis. That means the domain is x is the limit of the reals such that x is greater than 0. All my values are going to be greater than 0. My range is going to be every single y value. So y is the limit of the reals. And for my intercept, let's work it out. So I'm going to have 0 is equal to log 2 of x minus 3. So I'm going to add 3 to both sides. So I'm going to have 3 is equal to log of 2 of x. To get rid of the log, you're going to raise it to the power of your base. So I'm going to raise it to the base of 2. That means I'm going to have 2 cubed, which is 8. This goes away, and I get x. So my intercept is 8. So I'm going to have 8, 0 as my x-intercept. So that means I probably will have to extend my graph. So 6, 7, 8. And I'm going to have that's going to put a point right there. So that's one of my first points. The next thing I'm going to do is I'm going to use my t-table. And I'm probably going to have to do 2 t-tables because there's actual transformation here. And again, we're going to use our numbers that we usually like to use, which are 1 and our base is 2. So when we substitute that 1 into our original function, which is this one up here, log of 2x minus 1, you're going to have, remember, well, the one we're doing here is going to be log 2 of x. And on the next one is where we're going to do our shift. So there's going to be no shift here. We're adding 0 there. And we're going to go minus 3 there because there's a minus 3 that's a vertical shift up and down. And then there's no horizontal shift because there's nothing being added just to the x. Once we do log of 201, we know that is 0 from our properties. And then log 2 of 2, that is just 1 because of our properties again. So our x values do not change. They'll stay still 1 and 2. But our actual y values will change by -3. So 0 minus 3 is -3. 1 minus -3 is -2. So now we know our other 2 values to make our graphs. We have at 1 and then -3. This is 1 point. And at 2 and -2, this is my second point. And my graph should look something like that. So now we're going to work with natural logs. And natural logs are a lot like regular logs. They still have a a vertical asymptote. So my vertical asymptote, again, it's my h. So there's no k, so I can put 0 for k if you want. So my asymptote will be -3. So it'll be x is equal to -3. So we have an asymptote here. And then my domain, x is the limit of the reals, such that x is going to be greater than -3. All my values are going to be greater than 3 because I'm going to be on the right side of that horizontal asymptote. My range is going to be all real numbers. And to define my intercept, what we're going to do is basically the same thing that we did before when we're solving. So we're going to have ln of x plus 3 is equal to 0. Well, I need to get rid of the ln. The only way to get rid of the ln, if you look at your properties, is by taking the e of both sides. Whatever you do one side, you have to do the other side. So these basically go away, and you're going to have x plus 3. And we know e to the 0 is just 1. Subtract 3 from both sides. You're going to get x is equal to negative 2. So my intercept is going to be negative 2, 0. So we know we have 1 at negative 2, 0. We're going to have an intercept right there. Then we're going to do our table. So this one's probably going to have a transformation because we have a plus 3 there. So we're going to have x and y, and the one we're going to do ln of x. This is our parent function. And then our transformation is going to have a negative 3 shift there and 0 to the y. So when we're doing natural logs, the numbers that I suggest are 1 and e, because e makes everything simplified if you look at your properties. So if you go ln of 1, that is 0. Ln of e, that is 1. Then we're going to go 1 minus 3 is going to be negative 2. And we know that e is approximately 2.71. So 2.71 minus 3 is approximately negative 0.29. And these numbers stay the same because there's no shift. There was no vertical shift. So we're going to have negative 2, 0, which we already have, which is our y-intercept. And then we're going to have negative 2.9, which is somewhere around here, and 1. So our graph's somewhere there. And we're going to graph our line, and that should be our graph.